I think we want to finish this part here. This is not what you did on the machine, yeah? We checked the pressure switch. So we have this both parts here. Here is our pressure relief valve where you have to adjust the normal system pressure. You did it. Or which you have to reduce to the reference pressure. And then so we can measure the contact between these both pins here. And then we have here 160 bar as reference pressure. And we don't have a contact here. Then we use a wrench for adjust the pressure switch so long as you have the contact, yeah. And so you have a little bit fine feeling, yeah, to find exact the point where you find the switch, and you see the electric device give you directly response, contact or no contact, signal 1 or signal new, yeah. And this is what you have to know when you replace one of them by our machine. And you know, this is the same switch as we have also. We will see the next machine, the KP88, and we have the same switch here and also by this machine. And here we have a setting of 160 bar, and by other machine we have a setting of 190 bar. And we have different machines. For example, one machine there we have a setting of 85 bar. So the total different situations. Yeah. And here we need this signal only for create the bail ready signal by presses up. We press 818 up to 1160 by 504, 605 and 610. We don't have this switch, and so we create the bail ready signal a little bit different. Only from the time and from the signal, but I will show you, I think tomorrow, how we create the bail ready signal different, yeah. And so you can also test if the bail ready signal works or not. But normally, when you come to your customer, he will say you, the bail ready signal didn't appear in the last one. And when you say, I have no problem, then you can be sure that the bail ready signal comes. Okay. Here you find, for example, sometimes you see in our hydraulic diagram only the pressure relief valve and 3X, for example, and then you find the table on the same or the side behind where you find, okay, the 11.6 have a pressure here from 280 bar, and for example, the same hydraulic diagram is also by the V-press or by the VL 500, and there you have eject or you have to adjust the valve on 300 bars. Yeah, and so you find the table below. Yeah, the difference here is, for example, that here you have 2 cylinders, and here you have only 1 cylinder. So you think about what I told you: cylinder dimension and pressure give the pressing force. And here we have a bigger cylinder. You see 110 dimension, and here we have 150 dimension. Bigger cylinder, 300 bars, more pressure. 280 bar, and so we have the same pressing force by both machines. So we can calculate the dimension of the cylinder head or the piston head, yeah, dimension in square millimeter, multiplied with pressure, and then we get the pressing force. And this multiplied with this gives the same pressure as this multiplied with this. Yeah. Okay. Now we have new situation. I told you in the beginning that we have a motor and a pump. The motor runs with a fixed turning, 1,800 turnings each minute. And the pump make also such turnings and such volume on oil volume. And now sometimes the machine starts very slowly because we need a lot of oil for fill up the big cylinder. And then we have a trick on this side that we want to make a kind of turbo in the beginning. So we want to speed up the speed of the machine. And then we make a trick, and you see it here. We call them difference control. It means we want to use the oil which comes from the piston side, and normally the oil goes up in a tank. And here, a little bit more focused, means this oil which come here from the piston side should go in a tank. And here the oil have some possibilities. One way is this way, but you see that is a non-return valve. On this way, the oil can't come in a tank. The next way is this valve. You see that is a kind of pressure relief valve. If the valve is closed, the oil didn't come through this valve in a tank. What way is open? Only this way, against this non-return valve. Yeah? So, 3 ways, closed, closed. This way is open. So, the way the oil coming from the piston side, piston rod side, goes in this way and go in an R line, in this line, A line, and we add the volume of the pump with the oil coming from the piston rod side. So we get more oil on the R line, A line, and so we can speed up the cylinder movement in the beginning. Beginning means up to 130 bar. By 130 bar pressure on the R line, we move this valve in an open position, and then the oil from the piston rod side goes to the valve back in the tank. Until 130 bar, it can move here. It can only go here in the R line, and so we speed up the speed of the downwards moving. So we call them.
When you're pushing pressure up the other side, does it not?
When you're pushing here, this first.
No.
This on this side.
Yeah.
Okay, on this side we have no problem. The oil come from the B line here, the valve here. Bring the oil on the B line in the cross section, yeah, the B line. Then the oil come here. I think I have it on this side. No, that is open. Oh, okay. First of them. Before I come to your question, yeah? First of them. Okay, the oil here is closed. The oil can only go against the non-return valve. Open the ball, press the ball against the spring here, and then the oil come here, and we have additional volume in the A line, yeah? We have approx here 24 liters, and here come back approx 10 liters, I think about. I don't measure how much. And though we started with 34 liter, and so the movement is quicker, of course, yeah? More liter, more speed, yeah? So, and then when we reached the 130 bar, then we move this valve here in the open position, and then we have here also 130 bar, and though we close with this pressure also this non-return valve, because we have pressure against the ball and less pressure on this side, so we close this part. This is every time closed, yeah, you see. And so the oil, it's only possible that the oil go through the valve back in the tank, yeah, by lowering the machine or lowering the pressure. So after 130 bar, we lower or we reduce the speed, and we increase the pressure and increase the pressing force. And by the beginning, we don't need a lot of force because we have low material, so we can go faster. Yeah? And so this is a kind of as I turbo. We also use this in our big VK presses. Yeah? Okay? I'm not sure if the next slide, no. Okay, then I will come to your question. When we lift the press arm, yeah? Okay, in this way, only this is closed, for example, yeah? This is also here, we have only this possibility, you see here. We come here for the B line, only this way or this way, no more, yeah? So this way is closed, and this way is then open, because we can bring the oil against the ball, lift up the spring, and then the line is open.
But then it would open the A-line ball.
The A-line is open. Then when we lift up the press ram, the oil from the piston head side come out the A-line and go up in the tank.
But wouldn't it open the ball because you're pushing up the
This bar?
Yeah.
This ball is closed then. This that
Just
happened.
because of the positive pressure coming from the top of the cylinder?
This is closed then. We only lift up the press from here. Yeah. Here, okay. Here we have also a line. You see here, the pressure closed this part. Is that okay? That's what you mean here.
Yeah.
I forgot to draw the small line. You see here that when we have pressure on this line,
Yes.
yeah, then we have also the control line.
So
Yeah, yeah,
Okay.
and then it closed them from the back side. Okay,
I got
good tip. I have to draw also the small line that you see when we have pressure on this line, that we have pressure on the ball for close them.
Okay.
Otherwise, you are correct. The oil would also come.
I was like,
Only-
how does that work?
Very good. I think you are very good skilled. Okay, thank you for the tip. Yeah. Okay, here you see some components. We saw it on the machine. Yeah. And here you see also then the parts. We saw this part here, yeah, pressure. We saw also this part here, and we were only on the 820, and here we are on the 860, and this is the part for the speed control or for the pressure relevance control, yeah. So there's only this part. Here it's also the possibility to adjust them. So it should open by 130 bar, but don't touch it. Don't touch it, yeah? Because when we deliver this kind of valve, it is adjusted on 130 bar.
Okay.
Yeah? It's possible to adjust. You can hear it only. You can measure it, yeah? You can look 130 bar, and then you can hear if it opened or not, but it's not so easy by this noise of the press, yeah? And so, don't touch it. Okay? Then this part here is only the valve, yeah? It looks very small here. This part, or this part here, yeah, looks very small valve, yeah, only this part here, non-return valve, and when you screw it off, then is it that part, you see only this screw head, not more, and that is internal of the hydraulic block. But also let it on place only when you have seal problem. Sometimes you have a seal problem that you come see that there's oil coming out, then you have to tighten them a little bit more, or to change it, because when the seal is damaged, it's possible, yeah? Then we have here this part, you know, is the measurement point. MP is normally wrong, because it's M, measurement point, P means P line, yeah? Can also be the point on the T line or on the other line, yeah? And then by bigger presses, by VK presses, we have MP1, MP2, MP3, and so on, and MT, and a little bit different, yeah? But MP means measurement point, P line, P is our pressure line, yeah? By this V presses, yeah? And then the next one is our switch here. You know it? Pressure switch. Yeah, and our main valve, not more. And the valve you see here is adapted with the electric conductor, yeah, socket. And you see here the cable come from the power unit, yeah. And then we have here electric magnet. I will give you some pictures where you see it a little bit more in detail. Here's the same situation, other block, yeah, but the same components. I think it's clear now which are the different components and which is the function of these components, yeah. It's easy to replace some points, but when you open this part, you should be clear that you get oil out, yeah. So when you have to replace them, for example, make sure once that your system is pressureless, because when you have pressure on a system and you open such a screw, you can imagine what's happened. You get the oil shower, or you get the part in your face. Yeah, both is not so good. So make sure that your system is pressureless. So bring a small socket internal this valve, for example. You can make the system pressureless on this valve. You see here in the middle there's a round hole. Make a small socket, yeah, and press in once on this side and one time on the other side. And then you, sometimes when you have pressure in the system, you hear psht, that you lose the pressure, and then you can be sure that the system is pressurized. And then also make sure when you have to change some points that your press rem is not in the top position, because the press rem had a weight of approx 500 kilogram, and when you open this part, then psht, your press rem goes downwards and the oil will shower you. So make sure press rem in a down position. And then you can open them. It always comes a little bit oil then, but without pressure. Yeah? So I think that's clear. Yeah?
Yeah.
Okay? And think about hydraulic oil is unhealthy. Normally it's unhealthy. You should not think about, okay, it's very good for the skin, a little bit oil, yeah, a little bit cream. Hydraulic oil is unhealthy. Normally you should wear hand gloves when you work with hydraulic oil. Once it's not a problem, but when you work very often with hydraulic oil, you should wear hand gloves. Yeah, it's more healthy. And one tip also, when you have a leak in your system, for example, when a small seal is unsealed, yeah, and you have 280 bars, you can imagine there's one small line of oil is very sharp. Yeah? And when you have an unleaked system, for example, the oil is coming here and you don't see where the oil is coming out. You press and you detect them with your hand. I think you will cut your finger. Yeah? Don't detect sealing position with your fingers. Need a piece of paper. Yeah? Take a piece of paper and then you can see when the oil is spraying again. Don't touch with your fingers. Because when you get the injection with the oil, it's dead internal 7 days. Normally it's unhealthy. But you go to the doctor because you get such your finger.
Huh.
Yeah? So it's very risky to detect unseal system with your fingers. Okay? So, but normal jobs are, every job is unhealthy. Okay? So, one other tip, for example, when you go on bigger machines, you have such hydraulic plants and you see the hydraulic plant have the same symbols, for example here, smaller valve, for example. And when you want to find this valve on a machine, you see in the hydraulic drawing this valve and you want to control this valve. Or your technician on the phone said, please replace the valve here, YH1, replace this valve. And then you say, okay, and where I find this valve on the hydraulic block? Yeah. Normally you find a number here in a circle 1.1. You see the number? And by new blocks, you find the number directly hidden in the block, in the metal. And so it's clear when you have here the position 1.1 and here the position 1.1, then it's this here, the same valve. So you can find it very easy. Also here, the pressure relief valve 0.4, you find here the 0.4 and you know this valve is the pressure relief valve. So it's easy by new drawings and new hydraulic blocks. By older one, it's not so complete. Yeah? But by new one, I think it's now consequent done. Yeah? When you haven't this help numbers on the block, then you can find the valves with a trick. You see the drawing from the left-hand side to the right-hand side. And mostly the valve on the left-hand side is the valve from the bottom down. Yeah? So you see this valve here is this valve. The next one is the valve one step over them. Then the next and then the top one. So it's easy coming from the left-hand side, bottom up, you find the valves, mostly. And also a small help, when you here see the press ram stage 1, and you see here the door lock system, then you can imagine that the press ram have a big cylinder and the door lock system have a small cylinder. And when you have a big cylinder, you need a lot of oil, yeah, and so you need a bigger valve, yeah. So the valve have a bigger dimension because to have more oil, going through, yeah. So this is normally the big valve. The big valve every time for the main cylinder, and then the smaller valve for the next smaller cylinder. Here, for example, the pre-compactor or the door locking system by this kind of machine. Yeah. And now, sometimes you find a problem in the electric diagram. You saw it in the documentation, there are electric diagrams and also hydraulic diagrams. And by bigger machines, you have a list before you find the electric diagram here, the name of the electric valve. This is the socket on the valve, yeah? And there on the cable you find a sign, and this sign you find the number Y171, for example. And then you want to know, okay, what is the name of the hydraulic valve? It's different. And in this list you find then the hydraulic valve has the number YH4. And so you can find the sign of the machine direct on the cable. There's this one, and then you know, okay, this is then the valve, yeah? For example, one part now. And then you find here the valve is described in electric diagram on page 22D3. Yeah? And you have the list before. Yeah? And then you can in the electric diagram find the page 22. It's behind this logo here. Yeah? And you find the coordinate D3, and here you find the valve. It's looked a little bit different, but this is the valve for control, open the hydraulic part. Yeah? Give electricity on the socket, and then you activated the magnet, and then you move the valve. Yeah? And here you have the hydraulic plan. This is the electric. The same position here, electric plan, and here you find the hydraulic position. So, and now you find the list here, Y171 is here in the electric diagram, and you find here in the hydraulic diagram YH4, and then you find the hydraulic valve. It's a little bit searching, but with this table you will find from electric to hydraulic or in other direction, from hydraulic to electric. Yeah? But this is only by bigger machine. I think in future we will install also bigger machine here. Okay, this here is that what I told you. Make sure that your system is specialist. Take such a wrench, press in on the A and then on the B side of the way control valve, and then you can be sure that you have a pressureless system. So here is one V-Press 1160, a bigger one. I'm not sure if you have such big machine here in your portfolio. Here, for example, the difference is here that here we have one motor and you see two pumps. Yeah? The high pressure pump and the low pressure pump. And here we have the same situation. We pump with both pumps in the beginning because we want to increase the speed. And when we reach 130 bar, the same situation as I told you before. By 130 bar, we only want to increase the pressure and don't have a very high speed movement. And though we have here a valve that we shut off the low pressure pump by 130 bar. And though we open the valve, and then the volume of from the low pressure pump goes to the valve back in the tank. And then we only move the press ram with the high pressure pump. And you see here the high pressure pump had 20 liter volume and the low pressure pump 33 liter volume. Yeah? And here is a new valve on this part. Do you think what the valve has, what kind of function?
Use the pressure on the
Yeah, but we need pressure in the system, of course. Here we make sure that when we press the press ram on the material, yeah, with a high pressure with 280 bars, before we switch off the main valve for turning the press ram. So it's the same when you go with your car from the 4 gear in the backwards gear. Make no sense. First you have to press the brake. Yeah? And here, before we switch in the downward or the upward movement, we want to decompress the pressure. So we open for exactly, not exactly, approx 1 second this valve. So we reduce the pressure and then we can switch in the upwards position. Yeah?
So it's electrically controlled valve?
It's electric, you see, electric control. This part here, always, only this part here, only the electric controlled part. Yeah? See, every time you see electric controlled, and so we can activate it for a few seconds, or only, I think only a half second, I'm not sure exactly how long. We activate it and we reduce the pressure on the A line, and then we can move the cylinder in the other direction. Yeah? So we have it also by big machines, because when we have high pressure and then we move the big valve, then we get a big shock. You hear it, big noise, you're shocked. Yeah? And so we reduce the pressure and then we move in the other direction. Yeah? And here in this system we have the main cylinder for the main press plate, and this is the additional cylinder for the door locking system. And here you see now that we have A1, B1, and then we have the next cylinder, then we have B2, A2 and B2. Yeah? So we add A2, A3, A4, additional cylinder have additional numbers. Yeah? And the P lines is always the same. Yeah? P, P. Always one line. Yeah? Coming from the pump, you see this line connected to this valve and then connected to this valve. P lines every time the same, and also the T line, also a complete line. Yeah? The main line goes over the whole system. Yeah? Okay, also the different adjustments, you see the same hydraulic diagram by several machines, or by a couple of machines. Okay, in the beginning I told you that we have some restrictor with a turning screw for reduce the volume. Sometimes we have fixed restrictor. You see no axle. Yeah? You see here the restrictor have a dimension of 1.2 millimeters. So we fix the volume only for this pre-compactor. Or we fix the volume only for the door lock system with this kind of reducer. And the reducer is here painted directly under the valve. And when you search this part of reducer, you will find it in the body of the valve. I think I have a bigger photo now. Yeah? You see restrictor here, 2.5, smaller. Yeah? So we reduce the volume, reduce the speed of the cylinder. And this kind of restrictor you will find here. And sometimes it can be that you have a jamming in this small hole piece of metal or such else, yeah? And you have no working or no function in this valve. And then your technician on the phone said, open or clean the restrictor, not more. Clean the restrictor 2.5. You see it in this valve. And then you should know that you have to open the screws, 4 screws on this side, turn the valve, and then you find these restrictors. Or sometimes we have the situation that the door lock system goes too fast and make a hit, for example. And then our hydraulic colleagues say, okay, we have to reduce the restrictor from 2.5 to 2 millimeters. And then our technician have to replace, for example, this restrictor. And then they should know where they find these parts. Okay? Also clear.